Now we are going to solve the rest of the questions of the assignment from numbers 41 to 80. Now the 41st question, log 2 to the base 10 is equal to 0.3010. Then the value of log 25 to the base 10 is. Now log 25 to the base 10 can be written as log to the base 10 100 upon 4. Therefore, this can be written as log to the base 10 100 minus log to the base 10 4. Now this expression again can be written as 2 log to the base 10 10 minus 2 into log to the base 10 2, since we know that 10 is equal to 10 square and 2 is equal to 2 square, and we write the indices at the left side of the log. So this becomes, now log 10 to the base 10 is equal to 1. So this becomes 2 minus 2 into log 2 to the base 10, which is equal to 0.3010. So the answer becomes 2 into 0.3010. So this becomes 2 into 0.6020, which is equal to 1.3980. So in 41 question, answer B 1.3980 is correct. 42nd question, log 2 is equal to 0.3010 and 5 raised to x is equal to 400. So x is equal to, now we see that 5 raised to x is equal to 400. So this can be written as x log to the base 10 5 is equal to log to the base 10 400. Now x 5 becomes 10 by 2. Therefore this can be written as log to the base 10 10 by 2 upon, now 400 becomes 4 into 100, which again becomes log 10 to the base 4 plus log 100 to the base 4. Similarly, LHS becomes x log 10 to the base 10 minus log 2 to the base 10 Now we find that log 10 to the base 10 becomes 1 and log 10 to the base 2 becomes 0.3010, and log 4 to the base 10 becomes 2 into log 2 to the base 10, which is equal to 0.6020, and the value of this expression log 100 to the base 10 becomes 2. Therefore x becomes 2.6020 upon 1 minus 0.699. So the value of x is approximately equal to 3.72. So the answer of the 47th question is B 3.72. 43rd question, log 40,000 to the base 10 minus log 4 to the base 10 can be written as. Now this expression can be written as log to the base 10 40,000 upon 4. Therefore 40,000 upon 4 is equal to 10,000, which is equal to 10 raised to 4. Therefore this expression can be written as 4 into log 10 to the base 10, but the value of log 10 to the base 10 becomes 1. So the answer is 4. So in 43rd question, answer A 4 is correct. Now again we have to consider the following statements. Log to the base 10 0.1 square plus log to the base 10 1 plus log to the base 10 100 is equal to 0. Now in this question we see that 0.1 is equal to 10 raised to minus 1. So we can write this as log to the base 10 10 raised to minus 2. This expression is log to the base 10 1. Anything to the base 10 1 becomes 0. So the answer of this expression is 0 plus. This expression log 100 to the base 10 can be written as log to the base 10 10 square. Now this can be written as log to the base 10 10 plus 2 into log to the base 10 10. So but log 10 to the base 10 becomes 1. So this expression can be written as minus 2 plus 2, which is equal to 0. So option A 1 is correct. Now if we consider option 3, it is also equal to 1, as log to the base 10 10 raised to minus 1 plus log to the base 10 10 raised to 1 by 2. Now taking 1 by 2 on the other side, we get 1 by 2 plus 1 by 2, which is equal to 1. So alternative 3 is also correct. Now we see alternative 2, which is log to the base 10 log to the base 10 10 is equal to 1. Having this in exponential form, we write this as log 10 to the base 10 is equal to 10. Now again writing this in exponential form, as we get 10 raised to 10, but here the answer is given 1, so alternative 2 is not correct. So we find that only 1 and 3 are correct, so the correct option is A. 1 and 3 are correct. Next question, log 3 to the base 5 into log 625 to the base 3 equals. Now using change of base property, we can write these expressions as log 3 upon log 5 into log 625 can be written as 5 raised to 4. So it can be written as log 5 raised to 4 upon log 3. So this expression becomes log 3 upon log 5 into 4 into log 5 upon log 3. Everything gets cancelled except 4. So the answer of the 45th question is D. Option D is equal to 4. 46th question, log 2 to the base 10 is equal to 0.3010 and log 3 to the base 10 is equal to 0.4771. Then value of log to the base 100 0.72 is equal to. Now we first write the expression log base 100 0.72. Let this value be equal to x. Therefore this can be written as log of, using change of base property, we write this as log of 0.72 upon log 100. Log 0.72 can also be written as log of 72 by 100 upon log 100. Therefore this can be written as log to the base 10 72 minus log to the base 10 100 upon log to the base 10 100. Now log 72 can be written as log to the base 10 2 cube into 3 square upon, now we simplify log 100 to the base 10. Now 100 is equal to 10 raised to 2. So this value becomes 2 into log 10 to the base 10, which is equal to 2. So it becomes 2. Therefore we can further simplify this expression as 3 log 2 to the base 10 plus 2 log 3 to the base 10 minus 2 upon 2. Plugging up all the values, we can write this as 3 into 0.3010 plus 2 into 0.4771 minus 2 upon 2. Now this becomes 0.9030 plus this becomes 0.4771 into 2, which can be written as 2. So this becomes 0.9542 minus 2 upon 2. So which is approximately equal to minus 19286. We know that we write minus in logarithm in the form of bar. So the answer is 1 bar 9.9286. So the correct option of question number 46 is 1 bar 0.9286. Next question. The value of log 0.02 to the base 10 lies between. Now we know that 0.02 can be written as log to the base 10 2 upon 100, which is equal to log to the base 10 2 minus log to the base 10 100. Now which can again be written as log 2 to the base 10 minus 2 log 10 to the base 10. But log 10 to the base 10 becomes 1. Therefore, this can be written as log 2 to the base 10 minus 2. Now we find that value of minus 2, this value will always be greater than minus 2 and will lie between minus 2 and minus 1 only. So the answer of the 46th question is B, lies between minus 2 and minus 1. Now 48th question. If a, b, c are three consecutive integers, then log of ac plus 1 is equal to. Now a, b, c are integers, so b and c can be written as b is equal to a plus 1 and c is equal to a plus 2 since they are consecutive. Now log ac plus 1 can be written as log of a into a plus 2 plus 1. Now substituting this in terms of b, we can write as a as b minus 1 and a plus 2 as b minus 1 plus 2 plus 1. Therefore this can be written as log b minus 1 into b plus 1 plus 1. Therefore b minus 1 and b plus 1 becomes b square minus 1 plus 1. Therefore minus 1 plus 1 becomes 0. So the expression becomes log b square, but log b square is always written as 2 log b. So the answer of the 48th question is C, 2 log b. Now we have to find that given log 2 to the base 10 is equal to 0.3010 and log 3 to the base 10 as 0.4771 and value of log 1.5 to the base 10 is equal to, now we know that log 1.5 to the base 10 can be written as log 3 by 2 to the base 10. Now this expression can be written as log of 3 to the base 10 minus log of 2 to the base 10. So plugging in the values of log 3 to the base 10 and log 2 to the base 10, we can write as 0.4771 minus 0.3010, which is equal to 1.1767. So in 49th question, option B is correct. Now given that log 2 is equal to 0.30103, the number of digits in 5 is equal to, writing this expression in logarithmic form, we can write this as 5 raised to 20 as 20 into log 5. Now log 5 can be written as log of 10 by 2. Therefore 20 into log 10 by 2. Therefore this can be further written as 20 into log of 10 minus log of 2. As we know that log 10 is equal to 1. So this can be written as log of 1 and value of log 2 is 0.30103. So this can be written as 0.69877. So this can be written as 6.8877 into 10 raised to 13. Now we find that characteristic of the log is 10 raised to 13. So as we know that number of digits is always 1 greater than characteristic, so the number of digits will be 13 plus 1, which is equal to 14. So the answer of the 50th question is option A. So option A, 14, is correct. Now 51st question. The value of log 1 to the base 10 is. Now log 1 to the base 10 can be written as 0, because we know that anything of log 1 to any base is equal to 0. So the answer of the 51st question is B, 0. 52nd question. Which of the following is not true in general? Now we find that option A, log x plus log y is equal to log xy. It is a fundamental property or a fundamental result of log. So this is always true in general. Second, if we look at option C, log x minus log y is equal to log x by y. Now this is also a result in general. So this is also true in general. Now log y to the base x is equal to y raised to log x. This is also a result in general. So now let us look at option B. Log x plus log y is equal to log of x plus y. This is not always true in all the cases. So this option is incorrect. So the incorrect option is B. So the answer of the 52nd question is B. Log x plus log y is equal to log of x plus y. Now 53rd question. Which of the following is correct? First, log m raised to n is equal to whole log m raised to n. The option A is not correct. Second, log of m into n is equal to log m into log n. Option C is not correct. Fourth option, log of m minus n is equal to log m minus log n. This is not also correct. But using change of base property in option second, we find that the answer of the expression is 1. So the answer of the 53rd question is option B, 1. 54th question. The value of log a to the base b into log b to the base c into log c to the base a is. Now using change of base property, we can write this as log a upon log b into log b upon log c into log c upon log a. Now we find that everything gets cancelled. The value of the expression becomes 1. So the 54th question is having option B, 1 as the answer. Going forward to other questions, we have 55th question. Log x to the base e plus log 1 plus x to the base e is equal to 0. Then, now this expression can be written as log to the base e into bracket x into x plus 1 is equal to 0. So this can be written as log to the base e x square plus x is equal to 0. Now writing this term in exponential form, we get x square plus x is equal to e raised to 0. Now anything raised to 0 is equal to 1. Therefore we get x square plus x minus 1 is equal to 0. So in 55th question, option A, x square plus x minus 1 0 is correct. 56th question. Log to the base 4 x square plus x minus log to the base 4 1 plus x is equal to 2. Then the value of x is. Now we can write this expression as log to the base 4 x square plus x upon 1 plus x, since subtraction gets converted into division in log, is equal to 2. Now we can write this as x square plus x can be written as x into 1 plus x upon 1 plus x is equal to 2. Now we find that 1 plus x gets cancelled. So this can be written as log x to the base 4 is equal to 2. Now using change of base property, this expression can be written as log x upon log 4 is equal to 2. Therefore, log x can be written as 2 into log 4. Therefore, log x can be written as log 4 square. Therefore, x is equal to 4 square, which is none other than 16. So the option of the 56th question is D, 16. 57th question. You log x to the base 8 plus log 1 by 6 to the base 8 is equal to 1 by 3. Then x is equal to. Since the bases are the same, this expression can be written as log to the base 8 upon x by 6 is equal to 1 by 3. Now applying change of base property, this can be written as log of x by 6 upon log of 8 is equal to 1 by 3. This can be written as 3 into log x by 6 is equal to log 8. Now log 8 can be written as 3 log 2, since 8 is equal to 2 raised to 3 and 3 comes on the left side of the log. So this expression becomes x by 6 is equal to 2. Therefore, value of x is equal to 12. So in 57th question, option A, 12 is correct. 58th question. The value of log 1 upon log 60 to the base 3 plus 1 upon log 60 to the base 4 plus 1 upon log 60 to the base 5 can be written as log 3 to the base 60 can be written using change of base property as log 60 upon log 3, which is equal to log 3 upon log 60. Now applying the simplification over the whole term, we can write this as log 3 upon log 60 plus log 4 upon log 60 plus log 5 upon log 60. Since the denominators are equal, we can write this as log into log of 2, 3 into 4 into 5, since addition gets converted into multiplication in the log, which is equal to log 60 upon log 60, which is equal to 1. So the answer of the 58th question is D1. 59th question. If log 125 to the base 10 and log 8 to the base 10 is equal to x, then x is equal to. This expression can be written as log to the base 10 125 into 8. Now 125 into 8 is equal to 1000, which is 10 raised to 3. So the expression of the log becomes 3 into log 10 to the base 10, which is equal to 3. So in 59th question, option B, 3 is correct. 60th question. If log A plus log B is equal to log of A plus B, then we have to find out which of these following results is correct regarding this expression. Now log A plus log B can be written as log of A plus B is equal to log of A into B. Now this can be written as AB into A plus B. Now taking B on LHS, we get AB minus B is equal to A. Now taking out B common, we get B into A minus 1 is equal to A. Therefore, B is equal to A upon A minus 1. So in 60th question, option D, B is equal to A upon A minus 1 is correct. 61st question. If log m by n plus log n by n is equal to log m plus n, then we know that this expression can be written as log m by n into n by m, which is equal to log 1 is equal to log m plus n. So m plus n is equal to 1, and option A is correct for question number 61. Now 62nd question. The value of log 4 to the base 3 into log 5 to the base 4 into log 6 into base 5 into log 7 to the base 6 into log 8 to the base 7 into log 9 to the base 8 is. Using change of base property over the entire expression, we can write this as log 4 upon log 3 into log 5 upon log 4 into log 6 upon log 5 into log 7 upon log 6 into log 8 upon log 7 into log 9 upon log 8. We see that except log 3 and log 9, all the terms get cancelled. Therefore, this expression becomes log of 9 upon log of 3. Now, log 9 can be written as log 3 square, which eventually becomes 2 into log 3 upon log 3, which is equal to 2. So in 67th question, option A is equal to 2 is correct. 63rd question. If log of x plus 1 plus log of x minus 1 is equal to log 3, then x is equal to. Now this expression can be written as log of x plus 1 into x minus 1 is equal to log 3. Therefore, log of x square minus 1 is equal to log of 3. This expression becomes x square minus 1 is equal to 3. Therefore, x square becomes 4, which is none other than x is equal to plus minus 2. Since in the options plus 2 is present, therefore our answer is option B 2. So the answer of the 63rd question is option B 2. Next question, 64. If log 8 upon log 2 is equal to x, then x is equal to. Now log 8 can be written as log 2 cube upon log 2. Now log 2 cube becomes 3 log 2 upon log 2. Log 2 cancel each other, and the answer becomes 3. Therefore in 64, answer B is correct. 65th question. The value of x satisfying log x base 32 is equal to 0.8 is. Now writing this expression in exponential form, we can write this as 32 raised to 0.8 is equal to x. Now 0.8 can be written as 8 by 10 is equal to x. Now 0.8 can be reduced to simple fraction as 32 raised to 4 by 5 is equal to x. Thus, it becomes 32 upon 5th root of 5 into 4 is equal to x. Now 5th root of 32 becomes 2 and raised to 4 is equal to x. Now 2 raised to 4 becomes 16, so the value of x is 16. So in question number 65, option B 16 is correct. Now 66th question. If log x to the base 10 is equal to 1.9675, then log 1000x to the base 10 becomes. Now log of 10, this expression becomes log 10 cube x, since 1000 can be written as 10 cube. So this expression can be written as log 10 to the base cube 10 raised to 3 plus log 10 to the base x. Now taking 3 on the left side of the log, the expression becomes 3 since log 10 to the base 10 becomes 1 plus log x to the base 10 is 1.9675, so the value becomes 4.9675. So in 66th question, option B 4.9675 is correct. 67th question, the mantissa of log 3274 is 0.5150. The value of log 0.3274 is. Now, since the mantissa is given, we can find out the characteristic of the log easily. Now, 0.3274 can be written as 3.274 into 10 raised to minus 1. So we find that the characteristic of the mantissa in this case becomes minus 1. So this log becomes 1 bar 0.5150. So in 67 question, option C 1 bar 0.5150 is correct. 68 question, if log of tan of 1 degree into log of tan of 2 degree till log of tan of 50 degree is. Now writing this expression, we get log of tan of 1 degree into log of tan of 2 degree up to a point will come where we will have to calculate log of tan 45 degree up to log of tan 50 degree. Now we know that tan 45 is equal to log 1 and log 1 is always equal to 0. So the answer of the whole expression reduces to 0. So in 68 question, the answer is C, 0. 69th question, the characteristic in the log 6.7432 into 10 raised to minus 5 is. In 69th question, we know that characteristic is the indice of the 10 associated with the number. So in this place, indice of the 10 is minus 5. So the characteristic of the log will be a is equal to minus 5. So in 69th question, option A minus 5 is correct. Next question, if log 2 to the base 10 is equal to 0.3010, then log 10 to the base 2 is equal to. Now, using change of base property, we can write this expression as log 2 upon log 10 is equal to 0.3010. Now, as we can use any base in this change of base property, we take the base of 10. We take the base of 2. So, but log 2 to the base 2 becomes 1. And log 10 to the base 2 becomes equal to 0.3010. So, the value of log 10 to the base 2 will be 1 upon 0.3010, which is approximately equal to 3.322. So in question number 70, option C 3.3222 is correct. 71st question, if log 0.1 to the base 10 is equal to minus 1, so log 10 to the base 0.001 is equal to. Now 0.001 can be written as 10 raised to minus 3. So the expression becomes log 10 raised to minus 3 to the base 10, which is eventually equal to minus 3, as log 10 to the base 10 becomes 1. So in 71st question, answer D minus 3 is correct. 72nd question, if log A upon B minus C is equal to log B upon C minus A is equal to log C upon A minus B, then the value of A raised to A plus B raised to B plus C raised to C is. Let us suppose that log of A upon B minus C is equal to log B upon C minus A is equal to log C upon A minus B is equal to X. Therefore, the value of log A becomes B minus C into X, value of log b becomes c minus a into x, and value of log c becomes a minus b into x as equation 1. Therefore, taking log of a raised to a, b raised to b, c raised to c, we get log a raised to a plus b raised to b plus c raised to c. We get a into log a plus b into log b plus c into log c. Therefore, we know that log a, log b and log c, their values will be a into b minus c x plus b into c minus a x plus c into a minus bx. Therefore, this becomes abx minus acx plus bcx minus abx plus acx minus bcx. All this sum up to 0, which is none other than log raised to log of 1. Therefore, a raised to a, b raised to b, c raised to c is equal to 1. Therefore, in question number 72, option C, log of 1 is correct. Now, 73rd question, 16 raised to log 5 to the base 4 is equal to. Now, 16 can be written as 4 square raised to log 5 to the base 4. Now, as we know that indices goes on as the indices of 5. Therefore, this expression can be written as 4 raised to log to the base 4 5 square. Now, 4 raised to log to the base 4 becomes 1, which is equal to 1 into 5 square. Therefore, 5 square becomes 25. So, the answer of the 73rd question is C, 25. Next question, log of 5 to the base 5 into log of 9 to the base 4 into log of 2 to the base 3 simplifies this to log 5. Using change of base property, we can write this as log 5 upon log 5 into log 3 square upon log 2 square, since 9 and 4 can be written as 3 square and 2 square, and log 2 upon log 3. This becomes 1. This expression becomes 2 into log 3 upon 2 into log 2 upon log 2 into log 3. Every terms get cancelled out and the answer remains 1. So, the answer of the 74th question is B, 1. Now, we have an interesting question, that is log 7 to the base 2 is. Now, we have to find out whether it is an integer, prime number, rational number or irrational number. If we suppose that log 7 to the base 2 is a rational number which can be expressed in the form a by b. Now, writing this in exponential form, we can write this as 2 raised to a by b is equal to 7. This can be written as 2 raised to a is equal to 7 by base, since b gets transferred to the term 7. Now, we find that 2 raised to a is equal to 7 raised to b. We know that any indice of 2 can never be equal to any indice of 7. So, this relation does not hold good, and hence log of 7 base 2 is always an irrational number, since it cannot be explained in the form a by b. 76th question, if log a, log b, log c are in AP, then we first need to find the common difference of this AP. We can write this as log of c minus log of b is equal to log bc. So, the one expression of the common difference d is log b by c. Another expression of common difference can be written as log b minus log a is equal to log of a by b. Since this progression is in AP, arithmetic progression, both the terms already have to be equal. Therefore, log of BC must be equal to log of AB. Now, B by C is equal to A by B. Therefore, B square is equal to C. This proves that A, B, C are in GP. So, in 76th question, option A, B, C are in GP is correct. 77th question, the value of bracket 1 upon log x to the base q by p plus 1 upon log x to the base q by r plus 1 upon log x to the base r by p. Using change of base property, all the terms can be written as 1 upon log x upon log q by p plus 1 upon log x upon log q by r plus log upon x log r by p. Therefore, these terms can also be written as log of p by q plus log of q by r plus log of r by p. Since all the denominators become equal, we can write this as log x. Now, this expression log p by q plus log q by r plus log r by p can be simply written as log of p by q into q by r into r by p. Therefore, we find that all this product of all this expression sums up to 1. Therefore, log of 1 upon log of x. Now, log 1 to the base anything is always equal to 0. So, the value of this expression 0 divided by log x always becomes 0. Therefore, in 77th question, option D 0 is correct. 78th question. I feel that this is the longest question of the assignment. This question is, if log x to the base 4 plus log x to the base 2 is equal to 6, then the value of x is. Now, using change of base property, we can write this expression as log x upon log 4 plus log x by log 2 is equal to 6. Now, log 4 can be written as log x upon 2 log 2, since log 4 is equal to 2 square and 2 gets transferred to the left side of the log, plus log x upon log 2 is equal to 6. Now, the addition of these terms becomes 3 by 2 log x upon log 2. Since we are adding 1 plus 1 by 2 is equal to 3 by 2 is equal to 6. Therefore, dividing 3 by 2 to RHS, we get 6 into 2 by 3 is equal to log x upon log 2. Therefore, we get log x upon log 2 is equal to 4. Now, this can be simultaneously written as log x is equal to 4 into log 2. Therefore, log x becomes equal to log 2 raised to 4, since this gets transferred as an indice of 2. Therefore, x becomes equal to 2 raised to 4. Therefore, the value of x is 16. So, in 78th question, option D 16 is correct. 79th question, the value of 3 raised to minus 1 by 2 into log base 3 9 is, we first write this expression 3 raised to minus 1 by 2 log 9 to the base 3. Now, log 9 to the base 3 can be written as 2 log 3 to the base 3, therefore, which is eventually equal to 2. Therefore, the expression becomes 3 raised to minus 1 by 2 into 2. Now 2 get cancelled out. Therefore, the answer remains 3 raised to minus 1, which is eventually equal to 1 by 3. So in 79 question, option C, 1 by 3 is correct. Now the last question, if 10 raised to x is equal to 1.73 and log 1730 base 10 is equal to 3.2380, then x equals, first we write this term, log base 10 1.730 is equal to 3.2380. Now 1730 can also be written as 1.73 into 10 raised to 3 is equal to 3.2380. Now this expression can also be written as log 10 to the base, log 10 raised to 3 to the base 10 plus log 1.73 to the base 10 is equal to 3.2380. If we look at the expression number 1, 10x is equal to 1.73. Writing this expression in logarithmic form, we get log 1.73 to the base 10 is equal to x. So log 1.70 to the base 10 can be written as x, and the value of this expression becomes 3 into log 10 to the base 10 is equal to 3.2380. Now log 10 to the base 10 becomes equal to 1. Therefore this can be written as 3 plus x is equal to 3.2380. Therefore the value of x becomes 3.2380 minus 3, which is eventually equal to 0.2380. Now, so the option B is correct. So the answer of the 80th question is 0.2380. I hope you have enjoyed this video. Thank you.